Welcome back to Chapter 5 Study Guide. We're going to continue on here with number 14. So number 14 is asking you to write the expression as a single logarithm. So remember on 13, we kind of followed the same order of rules kind of. So the first thing that I am going to do is I am going to undo, or I'm going to do the power rule. So the 3 would move, the 1/2 would move, and the 2 would move. All of those have powers. So it would turn into be log base b of x cubed minus log base b of y to the 1/2 minus log base b of z squared. Now, once I've done the power rule, I'm going to change any of my fractional exponents, like 1/2, into a square root. So instead of it being 1/2, we're going to change it to be the square root. So log base b of x cubed minus log base b of the square root of y minus log base b of z squared. Okay, now we did a problem like this on the warm-up. It was similar to this with the 2 subtraction signs. And some of you guys got a little confused with the 2 subtraction signs, and you were thinking it was division and then division again. So, and it kind of helped you guys when we factored out that negative. So I'm going to rewrite this just as log base b of x cubed minus, because they both have a minus, I'm going to factor out that whole thing. So it'd be log base b of the square root of y plus log base b of z squared. Now it's plus because we factored out that negative, and now I've put the parentheses around it. Okay, so now that we've done that, and maybe that will, you don't have to do that, not at all. You can totally just know that, okay, these are both going to be in the denominator. But now that we've done that, so what I'm going to do is I am going to combine these using our product rule. So they have the same base, and so I'm going to combine those. So log base b of x cubed minus log base b, and now we're combining, so it would be the square root of y times z squared. Now if you were to write that in a different order and you put z squared in front of the square root of y, that's completely fine, because multiplication, it doesn't matter. With division, it does, right? So with multiplication, if it makes more sense to put the z squared in front of the square root of y to you, by all means do that. Okay, so then our next thing that we're going to do is we're going to apply the quotient rule. So we see we have same base and we're subtracting. So we are going to combine it by division. Now I am just going to write it over here since we're going to be at our answer. So it'd be log base b. And now, like I was saying, with division, it's important what goes on top and what goes on bottom. So the first one always goes on top, and then the rest will go on the bottom. And again, so if you want to write it like that, and so you don't get confused with what's under the square root, that's totally fine. And so it would be log base b of x cubed over z squared times the square root of y. Remember, if you can simplify something here, simplify it, but you can't. X, z, y, they're all different, so there's nothing we can do to simplify. Okay, so let's move on to number 15. Number 15 is asking you to do the same thing that we did up above. So I am going to start with that. So the first thing I'm going to do is I'm going to apply my power rule. So the 4, the 2, and the 2, we're going to all move those to powers. So it would be log base 8 of x minus 1 to the 4th plus log base 8 of x plus 1 squared minus log base 8 of x squared minus 1 squared. Okay, so then there are no fractional exponents here, so I don't have to worry about that. So at this point, what I'm going to do is I am going to apply the product rule. So we have 8, same, they're adding, so I'm going to combine them by multiplying them together. So it would be log base 8 of x minus 1 to the 4th times x plus 1 squared minus log base 8 of x squared minus 1 squared. Okay, so now that I've combined my two that are adding, I can combine what's now being subtracted by division. So same base, we're subtracting, so we're going to simplify it by dividing. So it would be log base 8 of x minus 1 to the 4th times x plus 1 squared all over x squared minus 1 squared. Okay, so at this point, this is as like condensed as we can go. However, there is a lot of simplifying we can do here. So what I'm going to do is I am just going to kind of write out what's on the inside. I'm going to factor x squared minus 1 because I can. Now, x squared minus 1, it's to the second power. So what that means and what that tells us, so we have x minus 1, and I'm just going to write the inside over here to kind of see it a little bit better. What that means is, so x squared minus 1, if we were to factor that, that would be x plus 1 times x minus 1. So since it's squared, all that means is we have x minus 1 times x plus 1, and then another x minus 1 and x plus 1. And so at this point, you can start canceling out what we have here. So x plus 1 squared, well, there are two x plus 1s in my denominator, so all of those will go away. There are two x minus 1s in my denominator, so I'm going to cancel out those. And so now instead of having 4 on top, we're only going to have 2. So I just kind of wanted to show it out a little bit bigger there. So now we can write it as simplified as possible. So it would be log base 8 of x minus 1 squared. Everything canceled out on the bottom. The x plus 1 squared canceled out here, and there were only two x minus 1s that were left. So that would be as simplified as possible for number 15. So let's move on to number 16. So for number 16, we have two exponential expressions on both sides of the equal sign. Now, when we have two exponential expressions on both sides and they don't have the same base, you know at this point that you either are going to apply ln to both sides or log to both sides. It doesn't matter, but I'm just going to apply the ln to both sides. So it would be ln of 5 to the x plus 2 equals ln of 7 to the x minus 2. Okay, so at that point, now that we've taken the ln of both sides, remember, it's just a process. Like, it's just like taking the sine of both sides, just like square rooting both sides. So whatever we do to one side, we have to do to the other. Okay, so we are now going to apply the power rule. We're going to move our powers to the front. So it would be x plus 2 times ln of 5 equals x minus 2 times ln of 7. Now, at this point, there are two ways that you can attack this. You can attack this without rounding, or you can attack this with rounding. You know which way I prefer. I prefer if you didn't round at all. So I am going to show you and I am going to walk you through without rounding. So what that means is we are going to first start by distributing the ln of 5 to the x plus 2 and the 2, and the ln of 7 to the x and the 2. So if we were to rewrite that, it would be x ln 5 plus 2 ln 5 equals x ln 7 minus 2 ln 7. Okay, so at this point, remember, our end goal is to get x all by itself. So what I'm going to do is I'm going to move all of my x terms to one side of the equation and anything without an x to the other side of the equation. So I'm going to subtract x ln of 7 from both sides. And so I have x ln of 5 minus x ln of 7 plus 2 ln of 5 equals negative 2 ln of 7. Okay, so I moved all my x terms over. Now this guy doesn't have an x term, so I want to move it over by subtracting 2 ln of 5 to both sides. So I'm going to finish that up here. So x ln of 5 minus x ln of 7 equals negative 2 ln of 7. Now remember, to move this over to this side, we have to subtract it, so minus 2 ln of 5. Okay, so now what you should notice is on this side, we do have a GCF. Both terms have x in it, so we can factor out x from both terms. So x times ln of 5, ln of 7, and then equals negative 2 ln of 7 minus 2 ln of 5. And so again, our goal is to get x by itself, so all we would do is divide both sides by ln of 5 minus ln of 7. And now at this point, this is going to be your unrounded perfect answer. So let's do that in our calculator. So let's kind of walk you through that. Okay, so into your calculator, what you're going to do is I would first just do the top. So it would be negative 2 ln of 7 minus, and I'm going to put this all in parentheses, so 2 ln of 5, end parentheses, end parentheses. And so that gets you negative 7.11, and then we are going to divide by ln of 5 minus ln of 7. Now notice a few things. One, I put parentheses around the entire denominator. If you don't put parentheses around the entire denominator, you are going to get a wrong answer. And then I ended my parentheses around 5, ended my parentheses around 7. So I should get that x is equal to 21.13. Now, if you rounded, which honestly I don't remember what I did in my work, if you rounded and you got something a little different, so if you rounded up at this point and you got something a little different, I will obviously follow your work through, and I will have on my answers the rounded answer that you would get to. However, I would prefer you guys not to round. It's more mathematically correct, and so you should get this as your answer. Okay, so on to number 17. There are a few ways that you can solve this. You could recognize, okay, you have a single number over here. You cannot get them to be the same base. And so you could change it to an exponential. Or you could just, like we did on number 16, you could take the ln of both sides. I am going to take the ln of both sides on my work. I did it a few different ways. I think I did the ln of both sides, and then I also changed it to logarithmic form. Whichever one you're more comfortable with is totally fine with me. So I'm going to just take the ln of both sides. So it would be the ln of 3 to the 3x minus 5 equals ln of 8. I'm going to apply my power rule. So move that to the front. So 3x minus 5 times ln of 3 equals ln of 8. And so then what I am going to do is I am going to first, now you have a few different ways that you could do this, but I'm going to first distribute. So 3x to ln of 3 and 5 to ln of 3. So it would be 3x ln 3 minus 5 ln 3 equals ln of 8. Remember, our goal is to get x by itself, so I'm going to add 5 ln of 3 to both sides. And then again, x needs to get by itself. These two things are being multiplied by x. So all I need to do is divide both sides by 3 ln of 3. 3 ln of 3. Okay, so I am going to plug that into my calculator. So into my calculator, I'm going to go ln of 8 and my parentheses plus 5 ln of 3 and my parentheses. And I get 7.57. And then I'm going to divide by that whole thing. I'm going to put parentheses around the whole thing, 3 ln of 3, and parentheses for the ln, and then n parentheses for the denominator. And I get 2.30. So x is equal to 2.30. Okay, so that does it for number 17. Let's take a pause here, and then I will continue the final problems on the last video.